Okay, today we're going to look at another example of a heat calculation. We're going to read through the problem, look at, answer our questions, and see how it goes. How much energy is needed to heat 125 grams of water from 25 degrees Celsius to 110 degrees Celsius? So, in all problems, we always ask the question, is there a temperature change? Ask that every single time so that you know which formula to use. So if we look at this, there is a temperature change from 25 degrees Celsius all the way up to 110. So we're going to answer yes. So we know we're going to have to use the formula Q equals mass times change in temperature times specific heat. But in this problem, we're going from 25 degrees Celsius all the way to 110, and we're talking about water. So we know that for water, we have a melting point of 0 degrees Celsius, and we have a boiling point of 100 degrees Celsius. You should be able to see that we're starting in between here, but we're ending above the boiling point. So in that case, let's draw out what this looks like. So here we have water, we have temperature in degrees Celsius, and we're just going to put time on this x-axis. So if we draw this out, so we draw the heating curve, we're going to start right here at 25. I'm going to say that's 25 degrees. Well, we know that we can heat up the water and we get to 100. Well, we should know, and I'll draw it in blue so you can see it. We know that here, we're going to call this the melting point or freezing point. Right here is our boiling point. Well, we're starting at 25. We're going to say that this is 25 degrees Celsius. We're getting to the boiling point. Well, it has to stay at some point during this boiling point, and then it's going up just a little bit. Maybe that's too far since it's 110, and it's going to end right there at 110. If we look at this, we basically have 3 different line segments, and I'm going to label them A, B, and C. So for this first line segment, now we can ask the question again, is there a temperature change? Ask the question and we say yes. So let's write out the equation for line segment A. So I'm going to say Q, and I'm just going to put an A there so we know we're talking about this first line segment. We have mass times change in temperature times specific heat. Well, this specific heat, we have to look at, is it a solid, a liquid, or a gas? In this case, we're talking about a liquid. So I wrote down here the different specific heats for water. It's always the same. For solid, for a liquid, this is where we're looking, right here. So you've memorized that. So this is going to be for a liquid. So let's put our information in. We have 125 grams. We have change in temperature. Well, we're going from 25 up to 100. That's what we're looking at, because that's when it spent time at the liquid phase. So, specific heat of the water, multiply all of this out, and we're going to get an answer, in this case, of 3918.7.5 joules. So that's line segment A. Now we've got to look at line segment B. Well, we're going to ask the question again. Is there a temperature change right here? Delta T? I'm going to say no, because the entire time it's staying right at 100 degrees. So we're either looking at heat of fusion or heat of vaporization. Since it's happening at the boiling point, we're going to use the vaporization. So heat of fusion is going to be the melting point, or you could say freezing point. Fusion is freezing. Vaporization is going to be at the boiling point. So we're going to use this for our second equation. So again, it's mass times heat of vaporization. Well, we still have 125 grams. In this case, we have heat of vaporization given to you in the problem, 2260 joules over grams. Notice in each of them, your units are canceling out, and you're going to be left with just joules. So this answer is 282,500 joules, comma there. We have one more line segment, this little tiny line segment of C. Again, we're going to ask the question. Notice every time we ask the question. And in this case, we're going to say yes. So we're going to use the same formula as A. The only thing that we're going to change is our specific heat. Instead of it being a liquid, we now have this as a gas. Anything above 100 degrees is a gas. So we'll use the 2.01. So I'm going to move this over here. Q of C in this case, mass 125.0 grams. Maybe I'll try to write this way so you can see it. Change in temperature. We're going from 100 to 110. So in this case, let me get rid of this, make it easier to see. It's only a 10-degree temperature change. Specific heat of the gas, in this case, is 2.01 joules over grams degrees Celsius. We're going to multiply all this across, and you should get an answer, since I've already written it out. I got an answer of 2510.5 joules. The one thing I didn't write for you, this was mass times change in temperature times specific heat of the water as a gas. So that's what this looks like. Now we have this number, and this number. And we want to know how much energy. So that's, if you look at it, it's total energy. Lots of times they'll say that in the problem, total energy. So we're going to add each of these together, and we will get a final answer. So 39,187.5 plus the 282,000, and so on. You should get 324,200 joules. We can look at significant figures. We only have 2, so we can say 320,000 joules of heat is what we need. So that's total. You can put it into scientific notation, you could change it into kilojoules, or you can just leave it in joules. So what I want you to do is I want you to use this information and solve this problem right here. I'm going to draw a line so you can see what we're talking about. How much energy is needed to melt 55 grams of ice, so we're at a solid state, from negative 25 degrees Celsius to 65 degrees Celsius. You're going to use the same specific heats, because those are always the same for liquid water, solid water, gas. Same heat of fusion and same heat of vaporization. So we want you to do this problem and bring the answer in. And that's it.